Hey everybody, it is me again. I just wanted to show you what I had been working on. Actually haven't touched it in a while, but I wanted to make this video. Did this back in February, got this working in February. Um, so what I'm going to do is I'm just going to go ahead and jump right into it. We're going to build this program, and actually before I get into it, sorry, this is a AVR assembly prime finder, 8-bit prime finder. So it searches between 3 and 255, and the reason why we're starting at 3 is because um, we know it's going to be divisible by 1, and if it's divisible by 2, then it's not a prime. So we're going to start at 3 for testing, so 3 to 255. And then also part of the key division in this program was inspired by sites.google.com/site/AVR ASM intro. So check out that site. It's got a lot of great information on math in the AVR microcontroller. So we're going to jump right into it. So we're going to build the solution, and that's good. And then we're going to start debugging and break. So I'm just going to step right through this program one bit at a time, explain everything. So we are loading 255. Also, you can think of it as all ones, 8 bits of ones into the temporary register. We're going to output that into the port B data direction register. And watch over here as I step through this next instruction. So that lights up. So that's now an output register. And we're going to keep stepping through this. So now we're going to load a 1 into the temporary register. Then we're going to load a 2 into the divisor register, because we're going to start with 2 for doing our math. And then we're going to add the divisor to the temp register to start at 3. And it's going to increment every odd number. So it's going to start at 3, then it's going to go to 5, 7, etc. So that's kind of I was able to have this one register kind of do 2 things. So anytime you can cut corners, save some cycles here and there, always helps. However, that said, there might be a better way to do this still. I'm a noob. I'm doing this for you as much as I'm doing it for me. So if there is a better way to do it, I'm all ears. Feel free to comment. All right, next we're going to compare the current number that we're testing, which is in temp. We're going to compare that with 255, because if we're at 255, then we know that we've reached the end of our test. So we're going to branch if equal, if temp, otherwise the number that we're testing is equal to 255. Moving on, we are going to move temp into answer. That way we have a copy of that, and answer is really our working answer, so that we're going to be working through that. We're going to be temp is going to stay put, and while we're actually doing the long division, it's going to be doing that working math in the answer register. You can see all those defined up here. And actually, while we do this, what we're going to do is display this as decimal. Let's see, that's the temporary register. This one's the answer. We're going to display this as binary, so you can see the bits shifting in and out. Same with this one. And register 19 is the divisor. So we're going to make that decimal. And register 20 is our counter. We can keep that hex, but I'll just change it to decimal. So we'll be keeping an eye on these 5 registers while we move through this program. Anyway, moving along. So you can already see that we've loaded the 3 in here, and our divisor is 2 currently. So we are going to move temp into answer. So you'll see this light up with 2 1s right here. And then we're going to subtract remainder from remainder, and 18, register 18 is remainder. It's currently 0, but if there happened to be something else in it, it would clear it. What we want to do, really what we're doing here, since we know it's going to be 0, we're really just interested in clearing all the flags up here. What's going to happen is the 0 flag is going to light up, which is cool. That's fine. We just want to clear the carry flags and everything. And that's done. And now we're going to rotate left through carry the answers. So keep an eye on register 17. You'll see these bits shift left. See, that just shifted left. We're going to decrement the counter. So take a look at R20, register 20. That's a 9. It's going to turn into an 8. Then we're going to branch if equal. We're going to branch to the loop exit if equal. But we are not equal, so we will not branch. So we're going to rotate the remainder, and nothing happens there because right now we're just shifting zeros into the carry register, and so zeros are being shifted back into register 18. All right, we're going to move on here. So we're going to subtract the divisor from the remainder. So we're subtracting this number from this number. And so it's going to go negative. See, it's negative. And since it's negative, we are going to branch only if positive. But it's not positive, so we're not going to branch. So what we're going to do is, in the next step, we are going to undo what we did by adding those two numbers back together. And this is going to go back to being a happy 0. So there we go. Now we're going to clear the carry flag. And shift 0. Let's see here. Clear the carry flag to shift 0 into answer. So we're clearing the carry flag, and that's going to end up shifting a 0 into this register. And we're going to cycle through this, and I'm just going to keep cycling and watch register 20 as we cycle through it. It's 6, 5, 4, 3, 2, 1. Now it's going to stop here. It's going to clear the 0 flag. And then it's going to test for prime. And if there is a number, if there's a 0 in the remainder, so if there's a 0 in here, then that means it is not a prime. But because we do have a number left over in this register, that means it is a prime. So stepping into the next instruction, branch to new prime if equal. So it is not equal, so we're not going to branch. So what do we do? We increment the divisor and watch register 19. That goes to a 3. We're going to compare. Does the divisor equal the number that we're testing? It does. So we're not going to, well, this next instruction says branch if new divisor is not equal. Now the new divisor, branch to new divisor if these two numbers are not equal. Well, they are equal, so we're not going to branch. So what we're going to do is output this number under test. We're going to output it to port B. And there you go. So you can see our answer is here. This is our prime number. And then the next step is to jump back up to new prime, where we're going to do this all over again. So watch register 16. This is going to increment to the next odd number because we know that even numbers are not primes. So here we go. We're going to add 2 to that. And then we're going to check to see if it's 255. We're going to go through this whole cycle again. So watch R20, 8, 7, 6, 5, 4, 3, 2, 1. We're going to check to see. And actually what we're doing here is we're going to clear the 0. I'm going to test for prime. It is not a prime. I'm sorry, it is a prime. It's going to branch if new prime, I'm sorry, branch to new prime if is equal, but it's not equal, so we're going to increment the divisor. So you can see R19 just changed to 3. We're going to compare those numbers to see if the divisor is equal to the number under test, the dividend. And it is not equal, so we're going to go through this cycle again. So keep an eye on R20, 6, 5, 4, 3, 2, 1. So we're going to increment the divisor to 4. We're going to go through this again. We're going to increment the divisor again. We're going to compare it. We're going to find out that it is equal, which means we're not going to branch to new divisor. Instead, we're going to skip that instruction. We're going to go to output the value to the port B. So watch over here at port B, and you'll see a new value light up right there. So there's a 5. So what I'm going to do is I am going to actually, I've already got a breakpoint right here, so I'm going to cycle through this, and you'll be able to just watch every time it finds a new prime value. So keep an eye here, and also keep an eye on the cycle counter and the stopwatch. So here we go. So there's 7, 11, 13, 17, 19. Keep an eye on the cycle counter, 23. So right now it's gone through 8,324 cycles, or half of a millisecond. There's 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, 101, 103, 107, 109, 113, 127. So there's the first 7 bits of our 8-bit number all lit up. 131, 137, 139, 149, 151, 157, 163, 167, 173, 179, 181, 191, 193, 197, 199, 211, 227, 229, 239, 251. That is our last prime number, between 0 and 255. To get here, it has taken 572,272 cycles, and it took basically 35.8 milliseconds to get to this point. Anyway, I hope you enjoyed this. Let me know what you think. If you have any comments, questions. Like I said, this was as much for you as it is for me. This was a tremendous learning experience for me to do something like this. My brother inspired me to do something like this because he wrote a bunch of programs, a bunch of Prime Finder programs in different languages, just for his benefit, and that kind of inspired me to do something like this with assembler. But if there is a better way to do something, feel free to let me know. Anyway, thanks for watching.